special things that happen in a rhombus. I'm going to see if you can figure out what they are. I don't know if I can do this very well or not, but I'm going to try it. I'm going to actually I'm going to trace this rhombus on this piece of paper, if I can. A lot of people like to call a rhombus diamond, but there is a diamond. It's actually called a kite. Okay, so there's my rhombus. All four sides are equal. Everything is groovy. But now I want to draw in the diagonals. And something special happens with the diagonals in a rhombus. Because all four sides equal each other, I don't know if you'll notice it right away, but I'm just going to have you look at the diagonals in the. First of all, they bisect each other, so this piece is the same as this piece. This piece is the same as this piece. Do they get one tick mark or two? One. But there's something very special about those diagonals. Can anybody see it?
Does it make the same triangles?
It would make the same triangles because we're all in agreeing, since it's a rhombus, these three are the same, right? Those four sides would be the same. Sorry, that's so bright. See if I can dim that just a little bit. Okay. So is this triangle congruent to this triangle?
No. It doesn't look like it.
What about by side, side, side? Does this have a 1, a 2, and a 3?
It looks smaller.
Does this have a 1, a 2, and a 3?
Yes.
Does this have a 1, a 2, and a 3? They all have a 1, a 2, and a 3, so they all four should be the same, shouldn't they?
No, because they don't go in the same order.
I'll trace one and then we'll put it on there and see what happens. I'm going to trace this one. I'll even mark the sides so that we know where 1, 2, and 3 are. 1, 2, and 3. So if I flip this over and put it 1, 2, and 3, what do you think?
Oh.
And if I flip it over and put it 1, 2, and 3, oops, that one's a little bit off. My rhombus is probably a little bit off. 1, 2, and 3, and
It does not look like it would fit there. Yeah. It's too big. Like it looks like the sides are longer.
but you're saying that it does.
Yeah.
I agree with you. It doesn't look like this triangle's the same as this one, does it? But they are.
That one looks shorter and like longer.
Yeah. Yeah. I think it's because it's a reflection, because you actually have to take that and flip it over, and it's just skewed. It's just an optical illusion. Okay? So yes, it does make 4 congruent triangles. However, remember we said in all parallelograms these two were congruent to each other, didn't we? And didn't we say in all parallelograms that this one was congruent to this one? Right? So it does make 4 congruent triangles, and if you'll notice on this sheet, I didn't put that on that sheet at all, because that's not really unique. It's an interesting observation and a true observation, Ashley, but there's something even more special about these diagonals. Can you guys find it? Is it what?
Is it the midpoint?
Well, yes, it's the midpoint. We always knew that.
Something we don't know.
Mm-hmm. Something unique to only diagonals of a rhombus.
They angle bisect.
They angle bisect. Start with that, Drew. Say that again.
They angle bisect the angles.
Of the rhombus. So you're saying maybe this angle is the same as this one right here. Possibly. We got patty paper right here. Let's check it out.
Wait, I changed my mind.
I think it's a great theory to try. All right. So does that angle equal
Too big.
that angle?
No. It looks like it fits.
Well, I think it does. These should be the same size. Does that angle right there equal
Your computer's really slow.
that angle right there? Sorry about that. It's all Micah's fault.
Yeah.
What do you think, guys?
Yeah.
Oh, that's kind of cool. So what about these angles since they're a different size? You better check this out here. Oh, I don't know why I did that. Trace it onto here. What do you think?
Let's see.
Yeah,
Trace
it's too
it onto
fast.
here. Sorry,
It's too white.
it's working. Yeah, it's hard to see underneath there, isn't it? It's working. You're right, Drew. They do. They do. So let's get out our sheet. And let's write down that how would I say that in words?
Diagonal.
Yep, the diagonals.
Bisect the angle.
Good. The diagonals bisect the angles. That's a rhombus. The diagonals bisect the angle. You know, we didn't try that with the rectangle. What do you think about the rectangle? The easiest way to do that is to look at, I'm just going to cheat right here, right now. Here's a rectangle on my sheet that I know is a perfect rectangle. So let's look at the diagonals of the rectangle. Is this the same size as this one?
Don't look like
Is this the same as this? What do you guys think?
it. Yeah.
Yes?
No.
No?
No.
This one's bigger than this one, so the answer is no. You'll just have to believe me, okay? So it doesn't work for a rectangle. Okay, great. So now rhombus has all four sides congruent and the diagonals bisect the angles, but you're still missing one special thing. And I don't think you'll be able to see it. So I'm going to show it to you. If you can see my patty paper. Can you see my patty paper? Oh, here, I'll use this pink one. This is better.
It's 90 degrees.
It's 90 degrees. This one is 90 degrees. And if those two are 90, guess what? This is 90. And this is 90. So in a rhombus, the diagonals, how do I say that in one sentence?
Diagonals, the midpoint of the
When two
diagonal.
lines intersect at 90 degrees, what do we say those lines are?
Parallel
They're not parallel.
or perpendicular?
The diagonals are perpendicular. The diagonals are perpendicular. Only in a rhombus. Doesn't happen anywhere else. Doesn't happen in any other parallelogram. Only in a rhombus. Now, we got one more shape. If I take a rhombus and do something special with it like this, I now have a, did this side stay parallel to this side? And the right and the left stay parallel to each other. Is this side congruent to this side? Is this side congruent to this side? Are the opposite angles the same measure? Yes. Are the consecutive angles supplementary? Yes. Do the diagonals bisect each other? Yes, they do. So, this is a square. It's a parallelogram because it meets all 5 of these criteria.
Doesn't it meet all of them except for the diagonal?
Well, let's check them out. The diagonals are not congruent. Should I check that box or not?
No.
No.
No. Good. Does it have 4 right angles?
No.
Yes. Are the diagonals congruent?
Yeah.
Yes. Are all 4 sides congruent?
Yeah.
Yes. Do diagonals bisect the angle? What do you
Yeah.
guys think?
Yes.
If I drew a diagonal in here, would it make those exactly 45?
Yeah.
Yep, it would. The diagonals are congruent. Or they do bisect the angles. Are the diagonals perpendicular?
Yeah.
They are? You guys are just going to say they do?
Yeah.
Really?
Yeah.
Really?
Because if you take a piece of paper and you cut off all the edges and you flip them inside, it would equal a square.
If you take a piece of paper
Believe me, I've done it
and
before.
cut off all the edges, what are you doing?
Square.
Oh, I see what you're saying. I see what you're
She goes like
saying.
that and cut off all the edges.
Yeah, like this, like
If you took a square piece of paper, I see exactly what she's saying. And this piece of patty paper is exactly square. So this is what I think you're saying, Drew, is if you fold these in.
I do it all the time, guys.
Is this what you're saying? Is this what you're saying, Drew? If you start to sort of kind of make a paper airplane, and then you go like this, except maybe this isn't a perfectly square piece of paper. Maybe patty paper's not square. I thought it was. But you're right, Drew. If you do this and you do it right, those have to be right angles because those are squares. Those are edges of the square to begin with, right? Is that what you're talking about, Drew? Yeah. So yes, they are perpendicular to each other. The diagonals are perpendicular to each other.
Yes, huh, guys? I know.
Okay.
It's fine.
All right. Anything else special about a square? Trying to think about the diagonals of a square or anything else like that. I don't think there's anything more special about any of them. I think we got it covered. Okay. So I'm going to ask you to turn your sheet over, and I'm going to try to summarize everything we just said in a little chart. Do the best that you can and draw a little parallelogram in the top center of your paper. Do the best that you can.
Oh, God.
Okay.
Parallelogram.
Mm-hmm. There are, this is just a chart for parallelograms. A parallelogram can be special in 2 different ways. The first way is it could be squared up and made into a rectangle. All you do to make a parallelogram into a rectangle is give it 4 right angles. That's all you do to make a parallelogram into a rectangle, is give it 4 right angles. If you start with a parallelogram and do one thing special to it, it can end up, and these are really hard to draw, being a rhombus. That's a really ugly rhombus, but it is one.
How do you make it a rhombus?
The only thing special about a rhombus is you make all 4 sides congruent.
I can't.
They're very hard to draw. Very hard to draw. As a matter of fact, mine doesn't even look right.
I can't read that.
Okay, I have a question.
I'm just gonna draw some
Can't a
squares.
rhombus be a square?
Yep.
Okay, so I'm just gonna draw.
No, you're not. You're going to draw a rhombus. Okay, I'll read what I've got here. This is a parallelogram. If you give it 4 right angles, it becomes a rectangle. If you take a parallelogram and make 4 sides congruent, then it becomes a rhombus. If you take a rectangle and tweak it by giving it 4 sides congruent, you get a square. Just a boring square.
How do you spell rhombus?
R-H-O-M-B-U-S.
So you just put tweak?
I just put 4 sides congruent.
Oh.
That's what I put. I put 4 sides congruent. If you take this rhombus and tweak it
Oh, you a square too.
by giving it 4 right angles, then you also get a square.
Oh man, half a day.
So it's like flip flop.
Mm-hmm. Exactly. Let me know when you're caught up. Are you caught up?
Whoa,
So
okay, I did that
everything
wrong.
starts with parallel.
Except for I did two.
All of these are parallelograms. And all parallelograms are quadrilaterals. Okay? In summary.
We didn't put that on this.
No, we didn't. In summary, this is very, 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 very important. Everything below here is a parallelogram. A rectangle, a rhombus, and a square are parallelograms, okay? Everything below here
Square.
is a rectangle. Everything below here is a rectangle.
Square.
So that means a square is a rectangle. Okay? Everything below here is a rhombus. So that means a square is a rhombus
And a rectangle.
and a rectangle
And a parallel.
and a parallelogram. That's right.
All at the same.
A square is a rhombus and a rectangle and a parallelogram.
All at the same.
Okay? A rectangle is
Parallel.
a parallelogram. A rhombus is
Parallel.
a parallelogram. Is a rectangle a rhombus?
No.
No, because it's not below a rhombus, right? Is a rhombus a square?
Yes.
No, it's not
Oh,
below
wait,
a square.
no.
A rhombus is not below a square, is it? So a rhombus is not a square. A rhombus is just a rhombus. This is the weird part. A rhombus is not a square, but a square is a rhombus. A rectangle is not a square, but a square is a rectangle.
I've never understood how the
Okay? So every attribute that a rhombus has, a square has. Let's see if we did that on the sheet. Every attribute that a rhombus has, a square has, except for this one about the diagonals not being congruent. But I've kind of got that listed twice, and so I think that's probably the problem there. Okay? But you'll notice there are two things in the square column that are not in the rhombus column. That's why a rhombus is not a square, because a rhombus doesn't have these qualities. Okay? That's why a rhombus and a rectangle aren't the same thing, because they don't have the same qualities. But all of them are what? Parallelograms. Oh my goodness. Okay, now